In the following discussion, we are going to discuss trigonometric substitution. Okay, so the objective will be to use the trigonometric substitution to solve an integral. Okay, now the trigonometric substitution is to evaluate the integral involving the radical. So when we have a square root, right? So square root of something. So we are going to use the trigonometric substitution. Now the trigonometric substitution is used by combining the trigonometric identities. Now we learned this before, right? We have sine x plus sine square x plus cos square x, right, is equals to 1. So this is the trigonometric identity. And so by having this one, now we know that the cos square will be 1 minus sine square theta. Okay, and we have uh, secant square is actually 1 plus tangent square theta. All right, and the tangent square theta is actually secant square theta minus 1. So we are going to use this to apply into the radicals here. Now, as you can see here, this is a square minus u square. The a is actually a number, and the u is a function of x. All right, so this is actually the in the same pattern as 1 minus sine square theta. Okay, so the first one, right, 1 minus sine square theta is actually in the same pattern as this. And the second one, right, a square plus u square is actually 1 plus tangent square theta. Okay, we know that 1 square is actually 1, so right, this can be 1 square. Alright, so this one is actually in the form of a square plus u square. Alright, so we have 1 plus tangent square theta. And the third one, of course, it will be secant square theta minus 1. Okay, so secant square theta minus 1 square. So when we have the radical or integral in this form, so we can actually use a secant square theta minus 1 square to substitute here. Okay, now our objective is to eliminate the square root, to eliminate the radical in the integrand. Okay, now let's see the example how we actually use the substitution here to eliminate the square root. Right, we call this radical. Right, how do we actually eliminate the radical? Now, for example, if we have something like this, right, square root of a square minus u square, so we can use, let the u be a sine theta. So when the u is a sine theta, therefore, right, u square will be a square sine square theta. So we substitute, okay, this one, all right, into the u square. Okay, u square, substitute a square sine square theta, so we have this. Now after that, all right, we can actually factorize out the a square. So a square factorize out, so we have a square here, 1 minus sine square theta. So we have a square, all right, so 1 minus sine square theta, and this is actually cos. Okay, so this is equals to cos square theta according to the identity here. Okay, so 1 minus sine square theta is cos square theta. So we change this to cos square theta, and because both a and cos have square, so combine with the square root, so we can take away the radical square root and the square together. So we will have a cos theta. Now from here, right, it makes our integration process simpler. Okay, so right, this is the trigonometric substitution. So again, when we have something like this, right, do remember this is 1 minus sine square theta. So we let the u be a sine theta. All right, and when we have something like this, okay, a square plus u square, okay, remember, all right, this is in the form of 1 plus tangent square theta. So we let the u be a tangent theta. Okay, and when we have the form like this, we have, right, secant square theta minus 1. So we are going to let the u be a secant theta. All right, now the angle of the theta is very important as well. All right, so to apply this, all right, the theta must be from negative pi over 2 to pi over 2. Now, what is a negative pi over 2? Okay, first, now when we measure the angle, all right, the anti-clockwise rotation is a positive angle. Okay, positive angle. And the clockwise rotation is a negative rotation, negative angle. Now, pi over 2 is actually 90 degrees. Okay, so it means that now we use this substitution when the angle is between positive 90 degree to negative 90 degree. Okay, so within this range, we are going to use this. All right, for tangent theta, all right, the range is the same. All right, it's actually from negative 90 to positive 90. All right, however, for secant theta, right, if the a tangent theta for u is greater than a, right, we are going to use from 0 to 90 degree. And if negative a tangent theta, all right, for u is less than negative a, then we are going to use the angle between 90 to 180. Okay, so this is 90 to 180. So we are going to check this one, okay, later. So let's take a look on this example. Okay, now first when we want to integrate this one, we can see here, all right, we have a radical function here. All right, square root of 9 minus x squared. Okay, so this is actually in the form of 1 minus sine square theta. So we are going to take the u be a sine theta. So the u, which is this one, all right, be the a sine theta. So what is the a? All right, so this is actually in the form of 3 square minus x squared. So the a is actually 3. So we have 3 sine theta, all right, and let this be the u. Okay, so we are going to continue from here. Okay, so we have 9 minus x squared. This is in the form of 3 square minus x squared. So it's actually in the form of this. So we are going to let the u be a sine theta. Okay, so let this u be a sine theta. So what is the u here? This u is actually the x. So the x is a sine theta. Okay, the u is the x here when we compare. Okay, so now the x is a sine theta. So when we differentiate x with respect to theta, so dx d theta, we will get a differentiate the sine, cos theta. So we have this. Okay, so dx d theta is 3 cos theta. Okay, by the way, the a is actually 3. Okay, now after that, okay, square root of 9 minus x squared, right, now become the square root of 3 square minus 3 sine square theta. And we can, okay, 3 sine theta square. And from here we have 3 square minus 3 square sine square theta. Factorize out by factoring out the 3 square. We have now 1 minus sine square theta. And then we have, this is cos, so we have 3 square cos square theta. And after that, we can actually take away the square, and the square root, we have 3 cos theta. Okay, so this is how we get to change this one to 3 cos theta. Okay, so I just repeat one more time. So the 9 is actually 3 square. The x square is 3 sine theta square. So expand this, we have 3 square and sine square. So factorize out the 3 square. So we get inside here is 1, and this is sine square. So according to the trigonometric identity, this is cos square theta. So we change to cos square theta. And now we can eliminate the square and the square root. We have 3 cos theta here. Okay, now after that, now we can see we have another x square here according to the questions. So according to the question, we have x square here. So we are going to, all right, square the x. What is the x again? The x is 3 sine theta. So we square the x. We have 9 sine square theta. Okay, now we are going to substitute everything into the integration here, integrand. So first, all right, the dx here, okay, is 3 cos theta d theta. The x squared substitute with 9 sine square theta. And this one, the square of 9 minus x squared, is 3 cos theta. Okay, so after that, we can eliminate 3 cos theta with 3 cos theta. Okay, so now take away, all right, the 1 over 9 here. All right, take out the 9. We have 1 over 9 here. So we integrate this. Now, what is 1 over sine square? 1 over sine square is actually cosecant square theta, and we have a formula to integrate this. Okay, so in the previous discussion, we have a list of formula. So this is one of the list. So integrate this, what do we get? We get cotangent theta. Okay, we get negative cotangent theta. So we have negative 1 over 9 cotangent theta plus c. Okay, now after we integrate this, we have the answer in theta. We need to change this theta back to x. Okay, change the theta back to x. So how do we change the cotangent theta back to x? So let's draw a triangle here. Okay, now when we have x is sine theta, actually it means that the sine theta is x over 3. Okay, sine theta is x over 3. So let's say this is the theta. Okay, this is the theta. Now sine theta is the opposite over hypotenuse, right? So when we have the opposite over hypotenuse, so we can write the opposite as x. So the opposite is this one. This is x. And the hypotenuse is actually this one, this line is 3. Okay, so the length of this line is x, and the length of the hypotenuse is 3. Now, then we can use the Pythagoras theorem. So the Pythagoras theorem says that the length here, the adjacent, okay, let me write it down. This is the adjacent. The adjacent will be 3 square minus x square and the square root. All right, the square root of 3 square minus x square. So now from here, okay, we have this. Okay, so since sine theta is x over 3, then we can also use this theta to find the cotangent theta. Okay, so cotangent theta is actually 1 over sine, 1 over tangent, okay, the exact is 1 over tangent, and this is actually cos theta over sine theta. Okay, or we can say, okay, what is tangent theta? Tangent theta is actually opposite over, this is opposite over adjacent, and then we have the cotangent theta is the adjacent over opposite. So what is the adjacent? The adjacent is this, okay, square root of 9 minus x squared. So we have this adjacent is this one, so we write here. And what is the opposite? The opposite is actually the x. This is the opposite, so we put the x here. Okay, so now we can change the cotangent theta to x as square root of 9 minus x squared over x. So substitute back here, and now we can multiply. Okay, so it will be square root of 9 minus x squared divided by 9x negative plus c. So this is the answer for the integration. Okay, so now this is the trigonometric substitution, right? We use when we have the integration involve, right, the radical function.